Okay, good day. So we will be discussing about submerged and floating bodies in marine engineering. So introduction, buoyancy is the upward force. Ito yung buoyancy natin. Upward force exerted by a fluid in a body submerged in it. And it's responsible for the floating or sinking behavior of objects in the fluid. So this force is equal to the weight of the fluid displaced by the body as stated by Archimedes' principle. So buoyant force equals the density of the fluid times the submerged volume of the submerged times gravity. Okay, so since gravity is constant naman, so madali lang naman to. Okay, so submerged body. So a submerged body is fully or partially immersed in a fluid. So when a body is completely submerged, it displaces a volume of fluid equal to its own volume, and the buoyant force is equal to the weight of the displaced fluid. So, paano nangyari to? So we have a submarine here. So yung submarine, when submerged, it displaces water. So and the buoyant force is counteracted by the weight of the submarine. The submarine can control its depth by adjusting its ballast, changing the amount of water in its ballast tank. So to change the buoyant force, to change the weight um, of the submerged submarine, so yung ginagawa nila is inhigop o kumukuha sila ng tubig dagat, pinapasok nila sa loob ng ating submarine. And then pag um, pag pumasok na yung tubig sa submarine or seawater submarine, yun yung tinatawag na ballast natin. So lumulubog yung ating submarine. So a floating body is a body that stays on the surface of a fluid without sinking. So the condition for floating is that the weight of the body equals the buoyant force exerted on it. So a ship is an example of floating body. So makita naman natin, lumulutang siya. Despite the ship being made of steel, which is denser than water, the ship floats because it has a large hull that displaces a large volume of water. So the total weight of the ship is less than the buoyant force generated by the displaced water. So factors affecting floating and submerged bodies. So first we have density of the body and fluid. We have the volume of displaced fluid and the shape of the body. So density of the body of fluid, so mas mataas yung density, mas madaling lumutang. Okay, volume of displaced fluid, the amount of fluid displaced depends on the volume shape of the floating body. So larger displacement leads to a greater buoyant force. And the shape of the body, of course. So pag hindi naman ganun kalapad yung shape niya, so mas madali siyang lubog. Okay, so application in ship design, we have the center of buoyancy versus center of mass. So here is the center of buoyancy, here is the center of gravity of the ship, and we have the metacenter, which is also parang sabihin natin this is the pivot of our pendulum. So pag nasa baba yung ating center of gravity, so medyo stable siya, nasa baba kasi yung pero pag yung center of gravity is umangat na, so may tendency na ikot na yung barko kasi syempre yung mabigat na bagay is bubababa talaga yan. So ikot yung ating barko. Okay, so that's it. The stability of floating bodies is determined by the ratio between the center of mass and the center of buoyancy. Okay, so we have here an example of a semi-submersible ship. So yung nangyayari sa barkong ito is nagkumukuha sila ng dagat para lumubog yung katawan niya. And then pag lubog ng katawan niya, doon na papasok itong mga sirang mga barko or itong mga platform na ito. So lulubog siya, kukunin niya yung mga platform na ito, yung barkong ito, kukunin niya and then aangat siya ulit. And then dadalhin niya itong barkong to kung saan ito kailangang dalhin sa dry dock. Maybe itong barko ito ay sira na, wala na, hindi na kayang magtumakbo, kaya kailangan na ng semi-submersible ship na kunin siya. Okay. So ito lang naman siya, yung tubig is pinapasok niya sa ilalim na dyan, so lulubog yung barko. So semi-submersible siya, hindi siya submarine. Okay, so example, problems marine engineering shows stability of a ship. So ito yung para maging stable yung barko natin. So yung ballast water natin is ina-adjust natin para para yung buoyant o yung center of gravity natin is nasa baba palagi ng metacentric height. Okay. We have a submarine ballast system. So example, so pag nilagyan mo ng tubig, yan, lulubog yung submarine. Pag tinanggalan mo tubig, aangat yung submarine. Okay, that's it for the submersible and floating bodies. Okay, thank you for watching. So our next topic will be the pressure head naman. Okay, so see you on our next video.